Okay, so some of the questions you have, a lot of them have to do with this negative exponent rule. So we've had a lot of exponent rules in this unit. When you multiply and you have the same base, you add the exponents, and dividing, you subtract the exponents. So this is just another rule about exponents. If you have a negative exponent and then you have a fraction, what the negative exponent is asking you to do is to write this fraction upside down. So I flipped the fraction. See how the 5 was on the bottom and now it's on the top? And 3 to the third was up top and now it's down here. So when you use the reciprocal of a fraction, you'll notice there's still an exponent of 2, but the negative then becomes positive. So just the act of doing that. So if I had something like 2/3, something easier, and it was just to the exponent negative 2, that's the same thing as 3 over 2 to the positive 2. So just because I use the reciprocal, the negative exponent becomes positive. And that's something that we want to do all the time. This is not a good way to leave an answer. If you have a negative exponent, it's kind of just not proper to leave it like that. So as soon as I see any negative exponent through the work that I do, as soon as I see that, I'm going to use the reciprocal. And then I can go ahead and, okay, 3 times 3 is 9 and 2 times 2 is 4, and I can finish the question. Sometimes you'll notice though, like here we actually had a fraction to flip upside down. If you see something like this, 5 to the negative 2, there's no fraction there. It just looks like a number. So you always want to have a fraction that you can use the reciprocal to flip upside down. So if I just have a number like 5, then I imagine that that is 5 over 1, and then I flip that upside down. And then the negative 2 becomes a positive 2. And then 1 times 1 is 1, and 5 times 5 is 25. So we go on and finish our question that way. We have no negative exponents in our answers. Usually we'll end up with a fraction though as your answer. So that's all I did here. I see the negative exponent. I'm like, okay, right away, boom, don't like that. Those aren't good. So I'm going to flip this upside down. And then my exponent becomes positive. Then I do 5 times 5, right? So that's where the 25 comes from. And then when you have a base and the exponent has an exponent, you multiply them. So 3 times 2 is 6. So then 3 to the 6 is 729. So that's just a little test to see if you understand two rules: negative exponents and what to do, and also what to do when your exponent has an exponent that you know to multiply those together. So there's lots of little rules that help you finish off these questions. Here's another one. This looks pretty crazy. Like you don't have the same base. You can't just subtract the exponents or anything because you would need the bases both to be 5 or both to be 2. So what can you do to simplify this? Well, as soon as I see that negative exponent, I don't like that. I don't want a negative exponent. But 5 isn't really a fraction. So imagine the 5 is 5 over 1. And then I would take that fraction there and I would flip it upside down. So that's what happened over here. And then the exponent becomes positive 1. So that's just 1/5. I can leave it just like that now because 1/5 to the exponent 1 is just 1/5. And 2 to the third in the denominator is 2 times 2 times 2, which is 8. But I really don't ever like seeing this. This always freaks me out. I have a fraction in the numerator and then I have a number in the denominator. So this might look like 1 over 5 over 8. Like that looks pretty scary when you see that. It's like I call these triple decker fractions. There's just too many fractions. There's too many numbers vertically. So then I like to take this line. Whenever that happens to me, I think this helps and makes more sense. This dividing line, I turn into this division symbol. So I write the 1/5 divided by 8, and I write it that way horizontally, which to me makes a lot more sense because I know that 8 is the same as 8 over 1. And the rule for dividing fractions is that you invert and multiply. It's just like one of those rules you probably learned a lot when you were younger, but people always forget. So if you have fractions, just a couple of rules. If you're adding fractions, like that, remember that you need common denominators to add fractions or subtract. If you're multiplying fractions, when you multiply fractions, one of the rules is that you go right across the top. 1 times 2 is 2, 2 times 3 is 6. We love multiplying fractions because you just multiply across the top, multiply across the bottom. But if you're dividing fractions, the rule is that you would invert and multiply. So I leave the first fraction how it is. I change to multiplication and I make this 3 over 2. Now I can just go straight across the top. I get 3 over 4. So we like multiplication because it's pretty simple. So we turn a division question into multiplication. So that's just like a little refresher on rules for fractions. So whoops, when I see this one that you just mentioned, that makes more sense to me. Now I'm going to flip that one upside down, the 1 over 8. I'm going to multiply straight across the top and straight across the bottom, and I get 1 over 40. So there's a lot to that, but like I said, anytime I see this, if I have a triple stacked fraction, I always would imagine turning it into division because it makes it look a lot easier to me, and then I know what I'm supposed to do. Another one you picked here. So the same thing happens if a negative exponent's in the denominator. What really is the easiest thing to know is that the y to the negative 2 could just come up to the numerator and become positive. So you could have just done that in one step. This is how I initially did it with all my exponent rules. I have x to the third. This is the same thing as y over 1. If I flip that upside down, I have 1 over y, but now my exponent becomes positive. So I'm still using this negative exponent rule of writing down the reciprocal, and then I have a positive. But again, I had a triple decker fraction. I had a x to the third and then 1 over y. How come? Oh yeah, 1 times 1 is 1 and y times y is y squared. So instead, I change this dividing line into that symbol because it just makes it easier. So now x to the third divided by 1 over y squared. I flip this upside down. I use the reciprocal and change to multiplication. That's the rule for dividing fractions. And then if that's flipped, I'd have x to the third times y squared, which is kind of hidden there. Because I'm flipping, or y squared over 1, I guess, if you want to show the 1. But that's why my answer just turns out to be x to the third y squared. And then I think there's one more. Oh yeah. So then another lesson we had, we're getting into these fractional exponents. And I just wanted you to know that if you see something like this, 14 to the 1/2, that number that's down on the bottom actually becomes the number out here. So this just means the square root of 14 to the exponent 1. So this number that's in the numerator becomes the exponent out here. It kind of stays up top. But this denominator number, if your exponent is a fraction, which you might have never ever seen before, the denominator is actually the root that we're trying to find. So when it's a 2, we're just trying to find the square root of 14. The 1 can stay up here, but this 4 means that that's actually the 4th root of 9. So it's saying that there's this number, probably a decimal, that multiplies by itself 4 times to give you 9. And this, if you see 35, the square root of 35 is the same thing as 35 to the 1/2, because we imagine there's a little 2 there and a little 1 there, which the 1 doesn't really change anything. But we can write, we can go in either direction, it doesn't matter. If you see something like 40 to the 1/5, that's asking you to find the 5th root of 40. So what times what times what times what times what, they're all the same number, multiply to give you 40, and it would be a decimal. And if you see something like 8 to the 2/3, we can go the other way. So that 3 means the cube root of 8, but then your answer is squared. So the 2 stays right up top. That's still your exponent, but the denominator actually is the root. So that means what times what times what gives you 8. And 2 times 2 times 2 is 8, but it still would be squared. So the answer would be 4 for that one. So it depends on what you see. So let's just do one more. If you had something like that. which is kind of something similar to what we had. This is asking you what times what times what times what times what. 5 times gives you 32. 2 times 2 times 2 times 2 times 2 is 32. So another way to write this is 32 to the 4/5. Maybe you see it written like that. But what that's asking you to do is find the 5th root of 32, which I think you might see on the video for your calculator is 2. So however you write it, but it's still to the 4th. So 2 to the 4th is 16. So you should be able to recognize those two values, that they are actually equal to each other. They mean the same thing.